Hi everyone, how are you? I'm Barihun from Sami Tech YouTube channel. Now today I will present you Emerging Technology course, the third chapter, which is Introduction to Internet of Things, IoT. Now in the chapter we will see about the descriptions of IoT from different perspectives, explanation of the history of IoTs from the beginning up to today's and the future, and the description of pros and cons of Internet of Things, explain how IoT works, explain the architecture of IoT, description of IoT tools and platforms, describe some application areas of the IoT. Okay, now the first definition from Internet of architecture board is given us, because many scholars or from many directions the IoT definition is defined by it is on their perspective. For example, IAB describes IoT as it is the networking of smart objects, meaning a huge number of devices intelligently communicate in the presence of internet protocol that cannot be directly operated by human beings. This is the point. Cannot be directly operated by human beings. So it is automatically communicated by itself, a smart object with another smart object. So but exist as components in buildings, vehicles, or the environment. That is the point based on this organization perspective. Good. The next one, according to IETF or International Internet of Engineering Task Force definition, IoT is a networking of smart objects in which the object have some constraints like limited bandwidth, power, and processing for achieving interoperability. This is another organization. And the third one is IEEE organization or communication category magazines. It defines as IoT is a framework for all things that have a representation in the presence of the internet in such a way that new applications and services are enabled. The interaction in the physical and virtual world in the form of machine-to-machine communication in the cloud. Just one a smart object communicates to another smart object. It is the ideas of the previous definitions, IAB, IETF, but the third organization, IEEE, is all things that have representation of the presence of internet. With the presence of internet, the communication of all things is described as IoT. The interaction between the virtual and the physical world or object in the form of machine-to-machine communication. Good. And then the next one, according to the Oxford Dictionary definition, IoT is the interaction of everyday objects of computing device through the internet that enables the sending and receiving of useful data. You hear this? Sending and receiving of useful data. All objects of computing device means electronics device through the presence of enabled internet communication. All definition is based on the internet or communication media or device. The term Internet of Things IoT, according to the 2020 definition, the conceptual framework is expressed through a simple formula, which is IoT is equals to service plus data plus network plus sensors. Sensor senses meaningful information from the environment which transmitted to the other object via networks. This data is already the issue or the value which is transported to service or changed or formulated and give service for end users, either machine, another machine, or person, or any end user. These four categories or objects communication or sum up is termed as IoT. This is the 2020 definition of IoT. Good. Generally, IoT is the frame, the network of physical objects or things embedded with softwares, sensors, and network connectivity. Softwares, sensors, and network connectivity, which enables these objects to collect and exchange data. The aim is collect and exchange data to the next or the previous object or to the next object. Collect some information from the environment and which transmitted to the next respondent or responsible object to feed necessary information or useful information from the environment. So simply it consists of any device with an on or off switch connected to the internet. On or off. This is the key or the long. Can be applied in several areas or domains or applications for connected industry, smart city, smart homes, smart energy, connected cars, smart agriculture, connected buildings and campuses, healthcare, logistics, among other domains. I have some information about smart agriculture. For example, in China, agricultures are conducted in a smart way in public or governmental investment agriculture areas or investment fields. For example, apple plant or fruit is conducted in a smart way. The technology senses the tree or the fruit's vegetable the fruit's status of their what I might say their productivity. For example, if disease happened or some unique phenomena happens in some certain areas of the plant, there may be a reason or a sign of disease. So the smart disease, the smart agriculture showed for or send some information to the respondent or responsible nearest individual reports the phenomena of the environment. Then the respondent or responsible individual takes a measure or looks manually or orders automatically managed by themselves to avoid this further expansion of the disease to other healthy plants of the apple plant, apple fruit. So this is one area of or one application areas of or domains of smart IoT Internet of Things application area, smart agriculture. Now in our country it is new. I have not new information about smart agriculture is implemented or not, but it is already implemented in China. As you see from the Internet of Things diagram here, these different areas, different application domains to apply Internet of Things. Good. Then the next one is the history of IoT. The Internet of Things has not been around for a long time. However, there have been visions of machine communicating with each other since the early 1800s. The Internet of Things as a concept wasn't officially named until 1999. One of the first example of Internet of Things is from the early 1980s and was a Coca-Cola machine located at the Carnegie Mellon University. Local programmers would connect by the internet of refrigerated appliance and check to see if there was a drink available and if it was cold before making the trip. Have you seen it? Internet of Things IoT is officially not given the area, but in 1980s the application is already implemented in Coca-Cola machine. So after a time it introduces the area and the name is given to implement this from the beginning of the 1980s. By the year 2030, the Internet of Things had evolved into a system using multiple technologies ranging from the internet to wireless communicating and from micro electromechanical systems to embedded systems. So the traditional field of automation, including the automation of buildings and homes, wireless sensor networks, GPS geographic position system, control systems and others, all support of the IoT is introduced in the beginnings of or in 2030. As we see the meaning, it is automation without human intervention. The system gives or takes a decision to take or to or take information to the next or the previous layer or the next responsible object or responsible organ. Good. Then Kevin Ashton, the executive director of Auto ID Labs at MIT, Massachusetts Institute of Technology, was the first person to describe the Internet of Things during his 1999 speech. He stated that radio frequency identification (RFID) was a prerequisite for the Internet of Things. He concluded, if all devices were tagged, computers could manage, track and inventory them. Tagging of things has been achieved through technologies such as digital water marking, barcodes and QR codes. Inventory control is one of the more obvious advantages of the Internet of Things. This is the first person who gives definition for IoT. Advantage, IoT improved customer engagement, IoT technology optimization, it gives reduced waste, it gives enhanced data collection. The data collection mechanism is enhanced. The waste of every aspect of resource is reduced. Technology optimization is also one aspect advantages of IoT, and the customer engagement is also improved. Yes, good. As the disadvantage, everything have its own advantage and disadvantage, as we know. As the disadvantage, IoT, as the number of connected devices increase, the more information is shared between devices, then the security problem is an issue also increased. If there is a bug in the system, it is likely that every connected device will be corrupted. Have you seen this? This is a big disadvantage. If there is a bug in the system, bug means either sometimes error, sometimes problem, sometimes mistake. As a whole, we take it as a mistake or an error in the system. If there is an error or a bug, it's likely that every connected device fail or corrupted, or the system failed out from their service. This is one disadvantage of IoT. Since there is no international standard of compatibility for IoT, it is difficult for devices of different manufacturers to communicate with each other. Actually, there are their own standards and codes but there is no standard of compatibility for each manufacturers. For example, for Toshiba, HP, Cisco, different electronic device manufacturer companies there, and their standard is different based on different perspectives, their size, their performance, their quality, their code. So this is difficult. Enterprises may eventually have to deal with massive numbers, maybe even millions of IoT devices, and collecting and managing the data from all those devices will be challenging. This is such a IoT. Good. Then the next one is security challenges of IoT. The security IoT creates an ecosystem of constantly connected devices over the network, which exposed users to various attacks. Security problem is one challenge of IoT. Privacy. IoT provides substantial personal data in extreme detail without the user's active participation. This is one challenge. The complexity. Some of IoT systems are complicated in terms of design, deployment, and maintenance of on a given technology. From the design, deployment, giving such service, and doing maintenance, it is complicated. This is the complexity of the challenges of IoT. Then the next one is flexibility. Many are concerned about the flexibility of an IoT system to integrate easily with another, several conflicting or locking systems. Some manufacturers or some frameworks may be or may not compatible to another. So this compatibility problem is an issue or is a challenge of flexibility from one manufacturer to another manufacturer, from one framework in terms of system deployment, from one system framework system to another system framework. Flexibility is also a challenge of IoT. A compliance. IoT complexity makes the issue of compliance seem incredibly challenging when many consider standard software compliance. This is also a challenge. So this is our challenges of IoT. Internet of Things. Good. Then the next one is how does it work? Internet of Things. We defined in terms of different perspectives with their advantage, disadvantage. So how it works? How does it work? Internet of Things ecosystem consists of web-enabled smart devices that use embedded processors, sensors, and hardwares to collect, send, and act on data they acquire. They collect, they manipulate or manage and transfers to the next labeled responsible object via sensors, transmitters, and communicable devices or hardware devices or embedded processors. So it is a web-enabled smart device because it works either wirelessly or wiredly. Most of the time it works in wireless way based on different platforms. IoT device shares the sensor data they collect by connecting to an IoT gateway or another edge device where data is either sent to the cloud to be analyzed or analyzed locally, either locally as I told you in wired way or transported into cloud in wireless way. So the device do most of the work without human intervention, automatically without human intervention. It conducts or performs its given task. through people can interact with the device. Although people can interact with the device sometimes, not all of the time, sometimes, if it is needed. Okay, architecture of an IoT. IoT device can be explained as a network of things that consists of hardware, software, network connectivity, and sensors. Hardware, software, network connectivity, and sensors. Hence, the architecture of IoT device comprises four major components. Sensing collects information from the environment. Network transmits, or it is a way of communicating one device to another device. Data processing, it is also processing or conducting or gathering meaningful information from the environment or from the sensing object. Then the application layers. The application layers addressing this information to responsible object or end object. For example, autonomous car, to change or make a decision to stop the car or to continue running on the way. For example, if there is an object in front of the road, then the sensor gives information about that object to the next object via network, any way of the communication technology. Then that information is processed on the processor and gives decision to the the end decider or the responsible object of that device, and that device decides either changing the way or the direction to pass that object in front object or stop by their own point. So this is four major components of IoT based on their architecture. As you see the diagram, this is the application layer, the top layer, and this is the first startup or the sensing layer, sensor layers. From this, the environment may have their own data, and the sensors collect some information from the environment and transfers to the network via a network communication device or by any one of this technology, either of this, or this. So based on this technology, different technologies, using different technologies, Bluetooth or other wireless technologies, via network layers and transfer to data processing layer. From this, the CPU, as you see, this is the CPU and this is database to check or decide the learning or the environment, this information is right or wrong, or based on their learning rate, decided by the processor and gives decision to the application layer. Then the application layer decides which types of measure can take. For example, just as I told you, for in case of smart car or mobile phone or other smartphones, homes or smart watches. So based on their application domain or area, the application layer decides what types of decision is made based on the information collected from the sensors or from the environments by the sensors. Okay, the sensor layer or the sensing layer, the main purpose is to identify any phenomena in the device, peripherals, and obtain data from the real world or the environment. Real world data from the environment is collected via sensor or sensing layer. It consists of several sensors, as using multiple sensors for application is one of the primary features of IoT. The Internet of Things primary feature is multiple sensors for the application, because it may have different categories of data from the environment. So each data is collected via different features of sensors. So sensors in IoT device are integrated through sensor hub. There is a sensor hub. It collects each sensor from different point or location, and it is a connection point for multiple sensors that accumulate and forward sensor data to the processing unit of a device. Yes, a sensor hub is responsible to collect each point of sensor from different points of the environment and forward the sensing data or the censored data to the processing unit of the second device or higher device. Actuators can also intervene to change the physical conditions that generate the data from the sensing data or censored data or collected data from the environment. It can shut off a power supply, adjust an airflow valve, or move a robotic gripper in an assembly process. It may shut off the power supply, adjust airflow valves, or move robotic gripper in an assembly process. The actuator. Okay, the three categories of sensor device in an IoT. The first one is motion sensor, to measure the change in movement as well as the orientation of the device. There are two types of motions: linear motion or angular motion. Linear motion refers to the linear displacement of an IoT device. Angular motion refers to the rotational displacements of the device. This is the motion sensor. The next one is the environmental sensor. Environmental sensor, motion sensor. The environmental sensor is embedded in an IoT device to sense the change in environmental parameters include sensors such as light sensor, pressure sensor, etc., moisture, and whatever. It includes it senses about this types of data from the environment, used in many applications to improve user experience. Example: home automation systems, smart locks, smart lights, etc. For example, light sensor senses the environment's light and automatically on the smart light or automatically offs the smart light. For example, light sensor senses during morning when the dark environment is removed and the day or the sun is rising on the east. The light sensor senses the presence of the sun and automatically off the smart light bulb. This is one example of smart sensor, light sensor. Smart locks, automation systems, home automation, and the like is work based on this principle. Then the next one is the position sensor. It is about physical positioning and location of the device or the location of that object or the device. The most common position sensors used in IoT are magnetic sensors and global position system, or which is called GPS sensors. Magnetic sensor and GPS. Magnetic sensors used as digital compasses and help to fix the orientation of the device display. GPS is used for navigation purpose in IoT device. For example, magnetic sensor it is a familiar phenomena in our mobile phone, smart mobile phone. When we rotate the direction of the mobile phone, your image or your video also rotated to upward, because it is one example of magnetic sensor. It senses the physical orientations of that object, the top, the bottom, left and right positioning of that image is managed by your magnetic sensor, which is found on your mobile phone. For example, your image in a normal way captured your photo using a snapshot or front camera, and you rotate your mobile, the picture is rotated upward. Your head is always on the top of your mobile phone. When you rotate, it also rotates your image's position. When you enable your smartphones, rotation is enabled setting, unless and otherwise it is the sensor is not sensing whether the image's direction is rotated or not. So this is one example of magnetic sensor. This is all about position sensor. And the next one is the network layer. Act as a communication channel to transfer data collected in the sensing layer to the next processing layer, which is between the two. In IoT device, the network layer is implemented by using diverse communication technologies. Example: Wi-Fi, Bluetooth, Zigbee, Z-Wave, LoRa, cellular network (CTC) to allow data flow from different device or sensing device from sensor layer to the next processing layer. It is a way of transmitting from different communication technology or network technology. It is the intermediate layer between the sensing layer, the bottom layer, to the third layer, the processing layer, which is found between the two network layer. It is a way of communicating or transmitting data to the next layer. Okay, consists of the main data processing unit. The data processing is the third layer. Consists of the main data processing unit of IoT device. It takes data collected in the make decision based on the result. In some IoT devices, example smart watches, smart home hubs, etc., the data processing layer also saves the result of the previous analysis to improve the user's experience. It learns from the previous and improves the user's experience. This layer may share the result of data processing with other connected devices via network layer also, because it is analyzed report of the collected data from the environment via sensor device. And the last one is application layer. It implements and presents the result of the data processing layer to accomplish disparate applications of our device. It is a user-centric layer that executes various tasks for the users. There exist diverse IoT applications, which includes smart transportation, smart homes, personal care, health care, etc. It is different perspective or areas. So the application layer displays the final output reports or decides any measure to take the advantages of that device or to accomplishes the targeted aim of the first responsible object or device. Good. Device and networks. Connected devices are part of scenarios in which every device takes to each other in an environment to automate home and industry tasks. IoT devices are meant to work in concrete for people at home, concert for people at home, in industry or in the enterprise. As such, the device can be categorized into three main groups. The first one is customer, the second one is enterprise, and the third one is industry level. It shows the number of users or the application, the number of applications implemented per individual or per object, or how much the service is engaged by the user. So consumer connected device. So first time consumer connected device includes smart TVs, smart speakers, toys, wearable device including smart watches and smart appliances. Smart meters, commercial security systems, and smart city technology such as these used to monitor traffic and weather conditions are examples of industrial and enterprise IoT device. You see this one. It is based on individuals level, but these smart meters up to smart city, it is industry or enterprise level IoT device. In this enterprise, smart sensors located in a conference room can help an employee locate and schedule an available room for meeting, ensuring the proper room type, size, and features are available. Good. This is IoT applications from IoT ecosystem. IoT, the top layer, the application layer. This is network IoT device. Different areas from different perspectives. As you see the diagram, IoT tools and platforms. There are many vendors in the industry level platform marketplace offering similar capabilities and methods of deployment. These IoT platform solutions are based on the Internet of Things and cloud technology. As I told you from the beginning, IoT is implemented most of the time cloud-based technology or wireless one, the Internet of Things, because each device is connected wirelessly, so they can be used in areas of smart home, smart city, enterprise level, home automations, healthcare, or automotive, just to name a few. This is some example. As you see, IoT platform and key features. There's different platforms based on their different applications. KAA manage an unlimited number of connected devices, set up cross-device interoperability, performance real-time device monitoring, performance remote device provision and configuration, collect and analyze sensor data, analyze user behavior and deliver targeting notifications. Okay, and the site where run any number of IoT application on a single site where instances. Spring delivers the core configuration frameworks are device rules, self-registration, and the like. Ellipse, Influx DB for event data storage, Graphian to visualize site where data, and the next one is ThingSpeak. Collect data in private channels, share data with public channels, MATLAB analysis and visualization, alerts, event scheduling, app integration, worldwide computers. This is IoT platform and key features. And the next one is device have directly integrated with Alexa, visualizing dashboard of your choice. It supports big data solutions such as Elasticsearch, Apache Spark, Cassandra, and Kafka for real-time and batch processing, connecting device and such and the like. Zeta supports a wide range of hacker boards, ThinkBoard, real-time data visualization, and remote device control, and the like is an example of IoT platforms and their key features. Applications of IoT. The versatile nature of IoT makes it an attractive option for so many business organizations and government offices. Various applications of IoT are: the first one is the agriculture. As I showed you the experience of China for indoor and outdoor planting, IoT used to monitor microclimate, sense soil moistures, nutrients, better control, smart integration and fertilizers systems, even disease, weather conditions. This is applications in the application of the agriculture. The second one is the consumer use. For private IoT device in the forms of wearable device, smart home makes life easier. Wearable covers sensors such as Fitbit, smartphones, Apple Watches, health monitors, to name a few. This is some example. For example, smartwatch is an example. Easy and familiar in our country. For example, this is And the next one is smart care or health care. Wearable IoT device let hospitals to monitor their patients' health at home. In hospital, smart beds keep the staff informed as the availability. There be cutting wait time for free spaces. This is the area, IoT application area in healthcare domain. The insurance. In the insurance application, insurance companies can offer their policyholders discount for IoT wearables such as Fitbit. Manufacturing, RFID and GPS technology can help a manufacturer to track a product from its start on the factory floor to its placement in the destination store. The whole supply chain from start to finish is connected for manufacturer applications. GPS and RFID technology is applicable for this area. Retail, online and in-store shopping sales figure can control warehouse, automation and robotics, information collected from IoT sensors. This is one application area. Then the next one is transportation. For transportation, the GPS is being utilized to help transportation companies to plot faster and more efficient routes for trucks hauling freight, thereby speeding up delivery times. It can be used to determine traffic patterns, parking space demand, and road construction and maintenance. In the transportation area, the GPS is being utilized or deployed and gives this much information for the users. Utilities. IoT sensors can be employed to monitor environment conditions such as humidity, temperature, and lighting conditions of the environment environment to the users via this device. These utilities can be gathered or collected and gives information for the users. The information provided by IoT sensors can aid in the creation of algorithms that regulate energy usage and make the appropriate adjustment. This information provided for IoT sensors or from the IoT sensors and can aid or help to create a new algorithm which regulates energy usage and makes the appropriate adjustment based on the feeding or the data fed by the information from the sensors. Then IoT-based smart home, the next section. A smart home initiative allows subscribers to remotely manage and monitor different home devices from anywhere via smartphones or over the web with no physical distance limitation. This is amazing issue or area. Somebody if their home is a smart home, he didn't expect to manage his house device or utilities inside his home without physical touch or physical contact. Without physical contact, virtually from remote, he can manage his home's utilities. For example, on or off his home light bulb, on or off his home's heating device. For example, his home weather is under expected or his need, he can on automatically remotely from or via from remote via his mobile phone, because his home is a smartphone home. So ግልጽ ለማድረግ ያክል ይሄን በአማርኛ ምን ልበላችሁ መሰላችሁ? ቤቱ ስማርት ሆም ከሆነ በአካል መምጣት ሳይጠበቅበት የቤቱ የዌዘር ወይም አየር ምንድን ነበር የሚባለው ይሄን ሙቀቱ የቤቱ ሙቀት እሱ ከሚፈልገው በታች ከሆነበት በጣም ከቀዘቀዘበት ከስራ ከመምጣቱ በፊት ባለበት ስራ ቦታ ላይ ያለ የቤቱን ዌዘር ቼክ ያደርገዋል በስልኩ በጣም አማይዚንግ ነው የሚገርም ነው ቼክ ያደርገውና እሱ ከሚፈልገው በታች ከሆነበት ምን ያደርጋል ሂቲንግ ዲቫይስን ኦን ያደርገውና ቤቱን እንዲሞቅለት ያደርገዋል እሱ እስኪመጣ ቤቱ ሙቆ ያገኘዋል ማለት ነው በሚፈልገው ዌዘር ከሆነ ደግሞ ወይም ደግሞ ትንሽ ሞቅ ብሎ ከሆነ ማቀዝቀዣ ይከፍታል አይሲ ማለት ነው ዜን እሱ ሲመጣ ቤቱ ቀዝቅዞ ያገኘዋል ማለት ነው በጣም የሚገርም ነው መብራቱን ቤት ሳይገባ ውጭ እንዳለ አብርቶ መግባት ይችላል ምክንያቱም ምንድን ቀደም ብያቸዋል ላይት ሴንሲንግ ዲቫይስ ቤቱ ተገጥሞለት ስለሚሆን ማለት ነው ስለዚህ ቤቱ መምጣት ሳይጠበቅበት ገና መንገድ ላይ ያለ ቤቱን መብራት አብርቶ ቤት ይገባል ማለት ነው ጀስት እንደቆየ ሆኖ ማለት ነው this is amazing smart device have the potential to share information with each other over internet connection as I told you from the beginning remote control appliance smart home appliance weather safety monitoring energy and water use erosion detection systems and the like it is amazing and the next one IoT based smart city in city the development of smart grids data analytic and autonomous vehicles will provide an intelligent platform to deliver annotations in energy management traffic management and security sharing the benefits of these technologies throughout society for example structural hull lighting safety transportation waste management greenhouse animal farm tracking compost field monitoring these lists of services or advantages is deployed for smart grid or smart city and the next one is the reference you can check or browse these references to get more information about internet of things from different perspectives from agriculture perspective from education perspective from different challenges or applications you can browse or search these much reference resources to know more about internet of things this is all about internet of things thank you